If C is the old reliable pickup, C3 is that same truck with power steering, ABS, and a backup camera. And it still runs on cheap gas. Is C3 a cleaner C for 2025, or just another detour on the road to modern systems programming? C is tiny, predictable, and everywhere. But some of its rough edges slow teams down. Ad hoc build setups, header juggling, error handling scattered across return codes and go-tos, and foot guns like implicit conversions. C3 keeps the C vibe, low ceremony, close to the metal, but trims the burrs and adds a few ergonomic rails. C3 is a small, C-shaped systems language designed to interoperate with C at the ABI level, while adding a real module system. An integrated build flow via project.json, plus a built-in command such as C3C build run, sane error handling with optionals, defer-based cleanup including defer try and defer catch, lightweight generics, slices, distinct and subtype checked types, operator overloading within reason, and contracts. That sounds like a lot, I know. But believe me, the pitch is evolution, not revolution. If you ship C today, game engines, embedded gear, graphics, real-time glue, and you don't want a wholesale rewrite in Rust, Zig, Odin, D, or C++, C3 tries to be the least surprising upgrade path. You can mix it with C files in the same project and move code over at the pace your team can handle. Let's start with the must-have, Interop. With C3, your structs, function calls, and calling conventions line up with C. That means you can keep your C libraries, your headers, and your platform shims. The learning curve stays shallow. Pointers, arrays, manual memory, the basic shape of C code is still there. C's build story is, well, a choose your own venture of makefiles, CMake, and bespoke scripts. C3 ships an integrated build. You declare targets and modules in project.json, and the compiler drives consistent builds with C3C build and C3C run. There's less time poking at toolchains, more time shipping code. Headers and preprocessors work, but they leak complexity. C3, on the other hand, has a real module system. You import what you use, the compiler knows the boundaries, and you avoid the include order minefield. Namespacing becomes a first-class concept, not a macro convention. C gives you returns and error no. Teams layer on conventions. C3 bakes in optionals for might fail results and adds defer, plus defer catch and defer try. That lets you separate the happy path from cleanup without the spaghetti. The point isn't sugar. It's fewer code paths to miss in reviews and fewer resource leaks that show up at 3 a.m. Resource lifetime is where real programs rot. In C, you hand-roll cleanup on every exit path. C3's defer stack executes on scope, exits in reverse order. A bit like Odin in that respect. The conditional variants let you log or free only when things go south. It's still explicit. You can see each cleanup in that defer section, and yet you only have to write it once. Sometimes you just want a type-safe pair, a growable array, or a tiny arena. In C, you macro it or duplicate code. In C3, you can write small generic helpers that monomorphize to concrete code. It stays close to how C folks think. Predictable code gen, readable errors, and no surprise metaprogramming cult. C3 has built-in slices, a pointer plus a length packaged together. So you stop passing raw pointers and guessing sizes. With slices, a for each that respects bounds becomes natural. It doesn't turn to a high-level language, just removes the "did we pass the length for this buffer?" class of bugs. Ever pass seconds to a function expecting milliseconds? I know, right? C compiles it just fine, though maybe it shouldn't. C3 lets you define distinct types, so you can't mix incompatible units by accident, and subtypes via inline when you really do want a struct to be usable where its member type is expected. It's the kind of guardrail that pays for itself the first time it catches a unit error. Enums in C are plain integers. Boring. C3 enums can carry associated static values and even multiple fields. As such, a state machine or a token stream stays compact but expressive. You still get that flat, predictable layout mindset, but just with fewer switch case footguns. Another nifty thing, C3 allows operator overloading, but you shouldn't recreate Perl by overusing it. Use sparingly for vectors, complex numbers, small math types. It makes call sites cleaner. The idea is readability, not magic. C3 lets you attach methods to value types. It's not objects, it's not inheritance. Don't worry, we're not recreating Java. Just nicer dot syntax for functions that conceptually belong to a type. C3 prefers free functions for global mutations. Use C methods when you're acting on a particular value. Preconditions and postconditions are built in. You can annotate function parameters and return values with requirements that fail fast in debug builds. Your assertions become part of the interface, not scattered comments. Turn them up in tests, keep them minimal, and release. On top of all its niceties, C3 cuts some of C's historical hazards. The big ones: no implicit unsafe conversions that silently narrow or reinterpret values. Goto is gone to preserve sane defer semantics. And the classic qualifiers are streamlined. The goal is less undefined behavior by accident and more, I know what this binary will do. If, as a hardcore C dev, you're wondering if C3 sneaks in some other modern but unwelcome solutions for its runtime, don't worry. There isn't a managed runtime or a tracing garbage collector. You still control memory, layout, and calling conventions. The added features are compile time constructs that disappear in CodeGen. If your C code was fast, that C3 translation should be just as fast, and often simpler to maintain. How do you try it without derailing your sprint? Pick a utility library, path manipulation, a small container, a file loader, port it to C3, keep the C headers and call from C as usual, replace ad hoc macros with small generics, use slices at the boundaries so your call sites become self-documenting, add contracts where you've seen bugs before. If it sticks, graduate a subsystem. If it doesn't, well, you've still shipped. How does this fit in the increasingly bloated systems language sphere? Well, let's briefly look at the competition and what they do. Rust gives you stronger safety guarantees and a big ecosystem at the cost of a steeper model. Zig gives you a minimalist, tool-first experience and defer from day one with its own style of error handling and no C preprocessor. C++ gives you everything and the kitchen sink and a kitchen-sized compiler. C3's lane is, I think in C, I want modern ergonomics, I need to keep my ABI and mental model. That's how C3's niche fits. No language is a free lunch. You'll still write allocators, think about lifetimes, and benchmark. The ecosystem is younger than C's. The compilers are newer, and your favorite library might not be a one-line import yet. The win, though, is in day-to-day clarity, fewer hand-rolled patterns, cleaner module boundaries, and fewer, oh no, we forgot to free that on-the-air path reviews. On a team, the biggest savings comes from the boring stuff, fewer header issues in CI, consistent imports, and error paths that are hard to forget. Junior devs can read the code and predict what happens on failure. Senior devs get to delete yakshave scripts and move risk out of macros and into the compiler. So, if you're a C dev, you should just jump right in, right? Well, not so fast. If your environment prohibits any new compiler, or your team has zero appetite for new syntax, stay in C and adopt a few patterns, such as explicit length carrying structs for buffers, staged cleanup labels, a consistent error type. With all that, you'll get 60% of the benefit with 0% of the tool churn. But if your code base is modernizing anyway, you have new module boundaries, fresh build scripts, library rewrites, that's the moment to try C3. Replace one crusty C utility with a C3 module and put it under real load. Let the results, not the hype, drive the decision. If you're a C dev looking suspiciously at all of these newfangled languages, I want to reassure you that C3 isn't trying to outsmart C. It's trying to tidy the workshop without moving the tools you reach for every day. If C is your daily driver and you want fewer paper cuts, C3 earns a weekend test drive. Thanks for watching. What do you think? Do you think C3 is a no-brainer? Or a subversive C saboteur? Or that C should just be shelled and replaced with one of the other languages I mentioned? Leave your comments below, and don't forget to like and subscribe for more techie talk from the Techie Shop. If you like this video, watch this video here for more tech talk.